Hey everyone, I'm David, aka Coma2000. Welcome back to my channel. This is the first video in a series where I present my favorite modules. I already made a patch or two, actually 3 patches from scratch with my top 10 favorite modules, so check those out if you want to know what to expect. In this video, we'll start with the evenVCO, which is one of my favorite modules ever. It's an oscillator. And while we're at it, we're also going to talk about oscillators in general. And I will show you one of my other favorite oscillators, Basal, and also saws from Squinky Labs, the Cloud Generator by E-Series, and the Sine VCO by Surge XT. And let's see first what we have here in front of us. So we have these 6 VCOs, including the VCV VCO, the one that comes stock with vcvrack. And also I have an LFO here. You will soon find out why, and the scope. And that's what matters the most. And up here it's just for the recording. I have a mixer, so I have the different VCOs fed into the different channels. So if you listen to that, you have one VCO here, another one, the third one. And we're going to compare the sound of those VCOs, because that's one of the interesting things about oscillators, is that they all sound different. So you have to find the one that you like the most and then work with that depending on what kind of sound you would want to achieve. And also I have Plateau, a reverb, as a sound effect. It's very minimal. It's just to make the recording sound a bit more pleasant on YouTube. And also a master module here, a recorder, and the audio module. So this is just the mixing and mastering part of it, which we will cover later. But let's get started with oscillators. And the oscillator is the main sound generating module of most synthesizers. You can get sound from other sources as well, like a noise generator or a sampler, but most synthesizers have a voltage controlled oscillator in them, or an oscillator in them. And in case of modular, where we control everything with the voltages, it is called a voltage controlled oscillator, or a VCO. And how do oscillators work? That's the question. And for that, I would like you to imagine an example. And I got this example from the Ableton website. I got inspired by that. They have an amazing interactive tutorial called Learning Synths. So feel free to check that out. And I have links in the description to that too. I'm adapting it a little bit. We are learning it through the modular environment, but the example there was about a bee which is moving its wings. Well, first it's sitting on a flower, and now I'm telling the story here. And in the meantime, I'm connecting this LFO to the scope. And this bee is just sitting there and not doing much. But then it moves its wing up and down. And it's doing this once every second. So let me change the time here so we can see the sine wave better. So what it's doing, it's moving its wing up, down, up, down, up, down, up, down every second. So that's one event, or one cycle, so to say, that it's moving its wing up and down. And here the scope, you have to imagine it like you are moving your pen. While the bee is moving its wing, you are moving your pen up and down at the same time. Up and down and up and down. And at the same time, someone is pulling the tape behind you. So, and that's just the time knob that we are controlling here, how quickly that paper is being pulled, and that this is the shape that's being drawn out, but it's just an up and down movement. But because we have the time scale here, the time setting, the dimension, then of course it's being drawn out in this manner. So in case of the bee, back to the bee, it's moving its wing, and now it starts moving its wing faster and faster. and now it's at about 2 hertz, and that's what 1 hertz means. 1 hertz means just 1 event per second. In case of 2 hertz, you have it up, 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 so you get 2 up and down movements every second, and we go faster and faster. But first let me connect this to the mixer, because now some magic is going to happen. I'm going to turn this up, and the B is starting to move its wing faster and faster, and at some point, I'm turning this down so you can hear it better. Let me start again. Let me go back down to a lower frequency, and then we go up. You see it's moving its wing faster and faster. We are moving our pen up and down like crazy, and once we are doing that fast enough, we are actually starting to generate some sound, a very low frequency, a very deep rumble. And the higher we go, the higher the frequency and the higher the pitch. And at some point, well, we are at 260 hertz, and if you listen to the VCO here now, these two are now at approximately the same frequency. They are both making a sound that we perceive or that we categorize as the C note, C4. And now you can see that the LFO and the VCO are almost the same module, the main difference being the frequency range at which they operate. The low frequency oscillator can go down to 0.0039 hertz. That's not for generating any sound, but for modulating parameters of other modules, such as VCOs. Whereas the VCO's main function is to generate sound. And with that, let me turn this down a little bit, we have covered the basics of frequency and oscillators, and we haven't seen all of the waveforms yet, so let me show you beyond the sine wave the other waveforms as well. And also let's listen to it. So the sine wave sounds like this. The different frequencies, we can play around with it. The triangle wave sounds like this, and it looks like, I have to move my paper very quickly, something like this. So it looks almost like a triangle, and it's kind of similar to the sine wave, but you're moving your pen a bit differently up and down, right? So you're moving it up and then down immediately, while at the sine wave you're kind of slowing down at the top and then back down. So it's more similar to how bees move their wings. Like, this is kind of difficult to change direction so quickly. Now the sawtooth wave looks like this, and it's a harsher sound, so let me turn it down. Actually, here there's like a little bending, but it should be straight, and it goes straight up and then down. I mean, it goes up and then straight down, up and then straight down. That's how you would have to move your pen to draw out this waveform, and that's how the bee would have to move its wing, up and then suddenly down, up and then suddenly down, and it would do that 260 times per second. Now let's listen to the square wave. This is a familiar sound, I think, to most of us, from my children's toys. And here, well, it's a bit distorted because it has some of these harmonics that you see up and down there. But basically, this is like going up, and then we stay there, and then we go down quickly, and we stay there, and up, and we stay there, and we go down and stay there. So that's how the square wave is being generated, and that's what it sounds like. And this is usually great for a bass note or bass through a filter, Filters we will cover in the next video, so keep looking out for that, and feel free to subscribe to not miss it. And for bass, you would have to go down in frequency, of course. Something like that. And now we have covered the main waveforms, and we have seen what they look like when they are drawn out visually on a scope, and also what they sound like when we listen to them through the mixer and the audio module. And that's about it for the general introduction about oscillators. So let's get to our main topic for this video, the evenVCO. The evenVCO is one of my favorite oscillators, mainly because it sounds great, and that's the most important thing, the sound. And also here we can easily go down a few octaves because it has this huge octave knob, so we can go down 1 octave, 2 octaves, 3 octaves. And then this would be a nice sub bass or bass. And then now what wave do we have here? The sine wave, of course. And also it's quite nice that the waveform is drawn out here so we can see it. And of course we could also visualize it, but I'm not going to do it with every single wave from now on. But of course you can not only change the octave, but you can fine-tune it as well here within a plus or minus 1 octave, or plus 7 semitones and minus 7 semitones. Also, of course, you could feed it in voltage to control the pitch instead of moving this knob up and down. So we have a volt per octave input. We don't have a sequencer now, or a keyboard, or a MIDI module. We have covered all that in the beginner tutorial, my 90-minute beginners tutorial. So this is sort of a continuation of that. So if it's too basic, I am sorry, but I hope you find this interesting and we learn something. So we have these 2 volt per octave inputs. That's already something interesting. So what can we do here? Maybe we patch in the LFO. That's what we have here. So I'm going to turn this up. This is now we are getting pitch information from here. And it's going like really high and really low because we are operating in like a 10 octave range because we have 10 volts up and down. We would it would be really nice to have a VCA or an Atenuverter. So I'm actually going to add that. So what we're going to do is we are going to go to Befaco and we'll find the dual Atenuverter, which is right here. It's a fantastic module that I really like. So we're, instead of feeding the triangle wave straight to the volt per octave input, we're going to first feed it into the Atenuverter, and that we are going to feed now into the volt per octave input. What am I doing here? So we are going from, okay, let's take the triangle wave again in here. And now we're going to control what's happening between this and this point. And we're going to feed this now into the volt per octave input. And nothing is happening because the Atenuverter is not open. So if we open it, and I can offset it, maybe lower the frequency a little bit so it goes a bit slower. This is controlling the amplitude, whereas this is controlling the frequency. The amplitude is just how high the signal is going. So you see the triangle now. And if I open the Atenuverter, it's going to go up higher. And of course, that also means that our pitch is higher. If we would go up to 10 volts here, we would be up by 10 octaves. So that's what happened earlier. Okay, now we go faster. Okay, I could play around with this for quite a long time, but I think you get the point. And if you feed in another voltage to the other volt per octave input, I don't know, what can we do? Let's add the square wave. Maybe add the sawtooth wave. But first, of course, we're going to feed this into an Atenuverter as well, otherwise we're going up and down 10 octaves here. They are going at the same frequency with the LFO, so but we can go down here. So you can see that the two are being added together. So it's just the sum of the two voltages that's happening here. Of course, we could achieve it with the logic module, but we already have this built in. I don't use these two inputs very often. I just feed in a voltage here for the pitch information. And you have another knob here that we haven't covered yet, and that's for the pulse width. For that, we have to go to the square wave. So let's listen to it again. Oh, sorry, yeah, this is quite harsh. And also, let's visualize it, because it's easier to understand once we see it. So here's our square wave. And I try to find the sweet spot here. And we've already seen the square wave, right? We're moving our pen up, keeping it there, down, keeping it there, up, keeping it there. And the pulse width parameter is basically controlling the ratio between how long we are keeping our pen up here and down there. So, and the sound, yeah? Now you see that this top part is shorter and the bottom part is longer. It's still from up and down, the up and down movement that we are talking about, it still takes the same amount of time. Just now when we move up, we keep it up there for a shorter amount of time, and then we move it down and keep it longer. Up, keep it, down, longer. Up, short, down, longer. But of course much faster than that at the frequency that we are setting here, so 100 times or more per second. So that's the pulse width, and you can control it here with this knob. But of course you have a CV input here to modulate it, so let's do that. Let's say with the Atenuverter, we are going to constrain a little bit the LFO. So let's take the sine wave now in here. And let me put this back to our basic position. I double click, then it goes back to the initial setting. And now if I modulate here and I open the Atenuverter, here the frequency, of course, we make it a bit slower to get a more subtle modulation, and then open it a bit more. And here's a tip that how I usually do this. I set it to a faster rate to hear what it will sound like at the extremes, at the minimum and the maximum, and then once I'm happy with it, I slow it down. So we get a more subtle change in the sound. It adds some variation to this note, this C note that we are playing. So you're always trying to make the sound a bit more interesting, and that's one way to do it, to modulate various parameters with LFOs. But we will cover LFOs and Atenuverters and all that in the future. I just couldn't resist So pulse width modulation covered, and now we get to the most interesting bit, this even output. Well, this VCO is called evenVCO, and the output is called even. So the question is, why? Well, let's look at it, and then maybe we can understand something and also listen to it. And we can see a very complex waveform here. So what is happening here is that it's a distorted wave, and you have some harmonics being added here to the main frequency which we have, and these harmonics are the so-called even harmonics. So you take the frequency that you have and then even numbers, 2, 4, 6, you multiply the frequency by these numbers and then add them together with different weights, but basically that produces this kind of sound. And those who are fans of mathematics will know that you could, in theory and practice, decompose this wave into just sine waves. So just go back, what we did, we could go backwards with the so-called Fourier transform, and it's fascinating stuff. But we don't need that for this, just for you to understand how this waveform is being produced and what harmonics are. And with that, I think we have covered even VCO. So let's now get to our next module, Basal from Vult. And Basal is, let's listen to it, a very simple module. I often use it for sub-bass. So if you go down a few octaves, here you have this octave knob again. These modules, they sometimes have the same control, sometimes different ones. So it's just about learning what is where, and then you are rolling. So let's go down an octave, and you can hear it's really nice bass sound. So just like this, it's already great. But you also can fine-tune it, and here you can go down 3 octaves, up and down 3 octaves, whereas here within an octave you can fine-tune it. And once we have our note, of course you could patch in some voltage here to the pitch input, and you don't have to turn these knobs, but you could still change the octave. But the interesting thing is these two modulations, and what they do. Well, the best thing is to look up the manual. So if you right click here and go to info, then you can see the author of this module and some other information, or you could even email the author, or maybe not, but you can also look at the user manual. So I click on this, then it should open if my internet is working. Well, yes, usually this happens, that I'm having some internet problems, but in that case, I will just tell you what these knobs are doing, and you can look it up yourself on the internet. This modulation knob is creating some overtones by distorting the phase of the oscillator. So it's some kind of phase shift, whereas the bottom modulation is adding or increasing the harmonics that we just talked about. So let's listen to it. Let's go up by an octave. Oh yes, that's the phase. different harmonics. Yeah, so you can just play around with these knobs. You can of course also modulate them with an LFO and just use the same trick that we talked about. We don't need the Atenuverter because it has built-in Atenuverters, which is fantastic. So we just take, well, what should we take? I press Control, then I can, or Command on the Mac, and then I can come with another cable here, and then I go in here, and then let's duplicate this LFO. Right click and then duplicate, and now we can set this to a different frequency, and then we modulate this too, and then I open the Atenuverter. So we got our nice bass. Let's see if we go one octave down, if it's still audible. Oh yes. Amazing. Sounds good. And that's about it about Basal and my two favorite oscillators. So now we just quickly cover some more oscillators which you can use as well. Of course, you can use any of these. These are all free modules, so you just have to download them or add them in the VCV, in your VCV library up here. So I haven't used these that often because these two, I have them in most of my patches, but I have used these because I did some statistics and I looked up all the modules that I have used at least once in one of my ambient patches. So let's cover these. Let's have a look and a listen. Ooh. Yes, that's Basal, of course. Oh, we are much higher now. Let's go down an octave. Let me turn this down a little bit because you can't hear me then. And these are, well, it says saws, so these are sawtooth waves. But you can see this is a stereo module, so we actually have two sawtooth waves mixed together. You can yourself mix together several sawtooth waves if you want, so you just go here and then we add another sawtooth wave to it. And we have to go up a bit. But what this module can do, well, it also has the octave knob, which is always great. I like that when a module has an octave knob. And here you can go up by semitones. Oh, we are at D. So we played a little bit around with this knob. You can also fine-tune it. You can change the frequency, of course. You have the frequency modulation depth. Oh, we haven't talked about frequency modulation yet. So, well, let's talk about it. For that, I will use the Atenuverter again. And I'm going to patch in here to the frequency modulation input. And you see it's called pitch modulation, frequency or pitch. So if you turn this up, let me see, I turn this up. In this case, the Atenuverter is not necessary, so let's not complicate things and just go, let me delete this LFO just to make everything a bit simpler. Let's go from the LFO to the FM input. You hear now the pitch is going up and down a bit slower because we have the LFO set up to a lower frequency. And here I can control the frequency modulation depth. So it's the amplitude that we talked about earlier of the frequency modulation. And now I will show you something cool. If I turn off this LFO, it starts modulating the frequency faster and faster. So let's have a look as well. Okay, this is the sound of the not the police anymore. Once we get to a high enough frequency, it's actually not the pitch changing anymore, but the timbre of the sound, so we get a different sound. And we're going to look at frequency modulation in more depth in the future, but I wanted to show you this. And let's see, have we missed anything here? Certainly. Okay, so what have we missed here? Let me turn this down a little bit. Well, we have two sawtooth waves here, and the cool thing about this module is that you can detune one of those. And you can also change the mix of the two sawtooth waves. Now we are at 0. And of course you could also modulate it with a CV input if you want. With the Atenuverter you open it and then changes the modulation of the detune, but turn up the frequency a little bit. Now you hear it. It's too much. We could modulate the mix as well if we wanted to. You also have the volt per octave input, of course, like on every other voltage controlled oscillator. That's a must. And then you have this trigger here, and that's going to synchronize it with a pulse or some other module. For example, you could use a square wave for that if you wanted to. So let me show you. If I patch the square wave into the trigger input, you can hear now that this tick, and also how the oscillator is being reset at every tick. I don't hear it, but well, but you have to listen carefully. And you have the frequency modulation input as well. And well, I actually missed it on the other modules, this hard sync input, because it's not implemented on the evenVCO, unfortunately, but we do have a similar input on the basic VCO here, this sync input. So let's give it a square wave and turn this down and listen to the now you hear that it's being reset or synced every time the LFO is giving it a pulse. So and there are two different settings here. One is hard sync and the other one is soft sync. And what is happening here? What's happening here is that we have two oscillators, and this one is called the master and this one is called now the slave. Those are the terms. And let's turn the knobs and then you will hear. If I We have to go to audible frequencies, so now we are using it as a VCO in a moment. And because this is the master, it's called the master for a reason. This is what determines the pitch actually at this point. And then you try to find the setting that you like. And in case of the hard sync mode, the slave oscillator is being synced every time that the pulse is coming, whereas in case of a soft sync mode, it's only happening when the wave of the slave oscillator is approaching its end point. So that's the theory, and the practice is listening, and playing around with the knobs. And here we set the frequency, let's say, to 261, and then you play around with the knobs until you get the sound that you like. So I think we have covered everything now on saws, and let's go to the next oscillator, the cloud generator, and let's listen to it. I think this is the one you can, yes. And let me turn it down because it's a sawtooth wave, so now you know the sawtooth wave, it sounds a bit harsh. Oh, it's actually a sine wave. Now I can hear it's not so harsh. But if let's listen to the sawtooth wave output. Oh yes. So yeah, I should have turned it down. Let's look at this module. What is different about it compared to the others? Well, quite a lot of things. You have the frequency here, you can fine-tune it. You have this spread knob, which changes the sound completely. And then you can add some chaos, some randomness to this. And then also you can change the density here. It's called density. And yeah, okay. So let's go down an octave or so. Too much. Okay, too much chaos as well. And let's look at the inputs. What do we have? We have the volt per octave input, of course, frequency modulation like we had here. We have the sync input, again, like here. We can modulate the spread. We can modulate the chaos. We can modulate the chaos bandwidth. And yeah, that's about it. You can get some cool sounds with this, so maybe we'll build a patch with this or something like that, so that this video doesn't get too long. And let's get to our last VCO here from Surge XT. They make quite cool modules, like basic modules, but with a twist. And let me show you what's so great about this. And let's listen to it. So we have the sine wave, yes, you know that by now. And well, it's called the Sine VCO, so of course it produces a sine wave only. And it's a stereo module. So one of the sine waves, one of the oscillators is detuned, and you can set the detune amount. Here, of course, you can set the pitch. So we can see it's at 261.63 Hertz, which is a C4. That's great. Oh, also great that if you change the pitch, it also shows to which musical note we are the closest. Oh. Oh. You can actually change the waveform here. So you start out with the sine wave, but then you can distort it with this knob. So wow. So now we are not really at a sine wave anymore. And also you can modulate things very easily. So you just say modulation 1 and you set it to feedback. You click here, you click there, and then you turn it up, which will set the Atenuverter. And now we just patch in an LFO, let's say. Maybe the frequency is too high. So now you can see the shape changing as well. And fantastic, this visual display, because we could patch into the scope, of course. We would see something similar if I can get the time right, which is quite difficult. So one big benefit of this is this also that it's really nice to visualize, plus the modulations are being set in a very creative way. And okay, let's see, what do we have here? We also have built-in filters, so we can filter out some high frequencies, and we'll cover, oh, I didn't want to do that. So now we're setting the modulation. Okay, very good. Okay, let me turn the modulation down. Okay, I will stop playing around with this, and well, you'll have a Volt per octave input, and you can re-trigger it, so it's similar to the sync input here. And with that, we have covered everything I wanted to cover in this video. I hope you enjoyed it. Let me know in the comments what oscillators you like the most. And with that, I will say goodbye. See you in the next one. It's about filters. Hopefully very soon, next week. Peace.